The wind is probably one of the more complex issues we'll have to deal with when we talk about sight. And that's because it's a fluid or acts as a fluid and can create all kinds of vortices. And that's kind of what's illustrated here. So we have some profiles of buildings, we have a prevailing wind flow, and then we have these planes that are intercepting the velocity of the wind. And you see these redirections of the wind and these eddy currents, which are just grade level vortices, um, hustling of the air, very common in urban environments. And they're very hard to calculate and understand, but they're very problematic because they affect the quality of the street life and activity. And that's where most people would complain about the effects of the design of a building and its street level wind energy. So when we site large buildings, many times we're required to do wind studies. And this is what we're looking at here. This is a physical model, and we'll cover the idea of doing digital models of this also. So here we have buildings in place. This is in a wind tunnel. If we look down here, you can't see the fan or the air generating system. It actually may be around a bend, but there are these vertical elements are designed to make the air flow in a more less turbulent way and a more laminar way, because we want, by the time it strikes the buildings, we want it to be behaving in a natural way. So we have this laminar vertical flow, and it looks like they're trying to interrupt the flow, maybe to mimic other site terrain that might be at the approach of this cityscape. And so, in order to change the direction of the wind, these are on a circular turntable, so we can rotate them and make the prevailing wind come from any direction we want. And then we can measure velocities at any given point. And sometimes we do this visually by introducing a medium like a pellet. And other times we can just put sensors in or smoke. We can use smoke also. And then here's the idea of a digital analysis of wind vortices through a site. Possibly the discussion here is the construction of this building, the prevailing winds that come in off of it. This looks like this could be, any large city, except for the iconographic building over here. But anyway, the idea here is that the red indicates high velocities, the blue typically indicates low velocities, and then we have this gradient in between. And so the placement of this building continues the high velocity wind now in a new direction in the course of the city. So this building's placement will have a remarkable effect on the site and the activities that happen over here. So there are many stakeholders who need to be addressed when we're planning these kind of projects and interventions. And like I said, there's plenty of ways now that we have to do these kind of site level evaluation. Eddy for grasshopper, eddy for eddy currents, wind simulation. We can make mock-ups in digital models and do those analysis. And this, once again, this idea of these effects that happen from wind speed, the bar effect, this idea of creating this blockage, creating a vortice effect behind a building by buffering the wind. And the intent is you would think that in the prevailing winds that these would be protected areas, but they can actually be buffeted with wind that's now coming from the opposite direction. The Venturi effect is the necking down and the high velocity. So we could have actually a low velocity prevailing wind here, but it gets concentrated down in the opening between the two buildings, and the velocity is greatly increased there. So it can make this a very unpleasant pass through between buildings. A few of these are all relatively self-explanatory visually. And keep in mind that the way to evaluate these will be ultimately to do these types of physical modeling wind studies. And not to leave wind as the complete enemy of our design process. Wind and the motion of air can drive our ventilation systems. So here we have a graphic from our text indicating this idea of using wind for ventilation and then directing the wind in a way that moves air and creates a cooling effect, but not so disruptive as to drive papers and other material away from your desk. So just another aspect of this idea of wind and the potential for ventilation. And here we have the same thing in the physical, the idea of a clear story, a ventilated clear story, and the ability to extract wind or drive wind into the building. And I guess one of the downsides of these is it's an active system. The window system has to be open in order for this ventilation to occur. But these are strategies to keep in mind and think about implementing in your project. And then here it is, kind of, this idea of natural ventilation. This is actually a graphic for all kinds of interventions with solar energy and earth geothermal heating and all of that. But I thought it was a nice graphic of this idea of the prevailing wind and the ventilation, natural ventilation created through the building, according to both its location of openings and design of the building elevation. So we'll end that there.